We are being recorded. Okay, so Sarah has a question on pretty blue. Okay, Sarah's question is on page 29. 29, number 41. Okay, several of them. Let me start with 41. All right, get there. And please be cognizant of what other people have asked. Okay, so like Sarah just asked for page 29, 41, 35, and 29. So please don't somebody else go and ask the same questions. Okay, that'll save some time. All right, so number 41 has quite a bit going on. So a big fraction in parentheses. Outside of the parentheses is the third power. Then inside we've got negative x squared, and that quantity is being cubed. We have a z. Then in the denominator we have in parentheses 2 x to the fourth y, and that is being squared. Okay. All right, so some of these problems you have choices on what order you want to do things in. Other times you don't have choices, but here you do. I think I'm going to take this whole big fraction, leave the 3 on the outside alone, and I'm going to get rid of parentheses, okay, inside the fraction. So first set of parentheses, I have negative x squared inside the parentheses, and we want to cube that. That means the negative 1 needs to get cubed, and a negative 1 times a negative 1 times a negative 1 is negative 1. So I'm going to keep my negative. Then I get x, and then anybody who's in my class knows I think you should really concentrate on the properties by words, not just trying to memorize what the formula is. So I'm going to say the words for this property that applies right now. When you're raising a power to a power, you keep the same base and you multiply the exponents. So that tells me multiply the 2 times 3. Don't add it, because if you put a 5 right here, you just got the whole problem wrong. Okay, so you have to know your properties. All right, so I get negative x to the 6th. Then I still have this z. In the denominator, the 2, as well as the x to the 4th, as well as the y, all of those factors are in the parentheses, and so I have to square everything. So make sure you square the 2, that's 4. Then I have x to the 4th that I'm raising to the 2nd power, and if you're not sure what to do with that 4 and that 2, just say your property words. I'm raising a power to a power, so I keep the same base, and I multiply the exponents. So I get 8. And then here I get y squared. Okay, I'm going to look to see if I can simplify anything before I worry about that exponent on the outside, the 3. And I notice that there's an x to the 6th in the numerator and an x to the 8th in the denominator. So let me change colors. That means 6 of these x's are going to cancel. So that's completely gone. And it's going to cancel with 6 of the x's in the denominator, leaving me with 2 x's. So I'm going to put that square there, and I'm going to circle this so I don't forget that I have that. Okay, I'm going to clean this fraction up. I still have my negative 1. I have a z in the numerator. In the denominator, I have a 4. I have that x squared, and I have a y squared. And then all of that still needs to get cubed. All right, so I'm going to cube my negative 1. I still have a negative 1. I'm going to cube my z. I get z cubed. I'm going to cube my 4. That's not 4 times 3. It's 4 raised to the 3rd power, and that's 64. And then x squared cubed means keep the same base, multiply the exponents, and same thing for the y. And there's my final answer. Okay, make sure that you simplify completely. I did. And notice that I have some steps that I took to get to my final answer. It's not just all of a sudden you know what the answer is. You have baby steps to take, so don't be afraid to take those. Okay, Sarah, I hope that helped. All right. Let's go to page 29, number 35. Okay. All right, so number 35 is 3 p to the negative 3 power, q to the negative 1, and then all over 8 to the negative 1, p q to the third. Okay, so these are all factors, and that's why I can do what I'm going to do next. I'm going to take each factor one at a time. I recommend that you go systematically in order from left to right, starting at the top. So I'm going to just take each factor one at a time and ask myself a question. 3, it's really to the first, even though we don't write that exponent. So since it's a positive exponent, the 3 stays right where it is in the numerator. Okay, my next factor is p to the negative 3. Since that has a negative exponent, that really means 1 over p cubed. So I'm going to put p cubed in the denominator. Okay, next I have q to the negative 1. So that's going to become q to the positive 1, but in the denominator. Okay, next I go down to the denominator. My next factor is 8 to the negative first power. So that's going to become an 8 to the positive 1 in the numerator. Okay, so the reciprocal, it goes up since it's in the denominator now. Okay, that p is to the first power, so I'm going to put that p right where it is right now in the denominator. And then q to the third, that is a positive exponent, so it also stays in the denominator. Okay, so my 3 times 8 is 24, so there's my numerator. My denominator is p to the fourth and q to the fourth. Oh, by the way, there's a property I can state. Okay, I have this p to the first times p to the third, and if you're not sure what to do with those exponents, then you would say, when multiplying like bases, you keep the same base and you add the exponents. And so there's your answer. So you better know your properties, guys. Okay, by the way, when there's more than one letter or variable in a term, and you've got these factors of variables, please put them in alphabetical order. It just makes it easier for teachers to grade. Okay, so that's why I have the p to the fourth before the q to the fourth. Okay, all right, page 29, number 29. Okay, this time we have 2t to the negative 3 all over in parentheses 2r raised to the negative 3 power. Okay, so notice in the denominator there are parentheses, but there are no parentheses in the numerator. So in the numerator, I'm just going to rewrite that, and I'm going to get rid of the parentheses in the denominator. Because of the parentheses, that means I want 2 to be raised to the negative 3 power, as well as the r to be raised to the negative 3 power. Okay, and that's one of our properties. I think it's property number 4, where if you have factors inside the parentheses, then each factor gets raised to that power. Okay, so now that I have it written like that, I'm going to say the exact same words that I said on the last example. I'm going to go systematically, starting from the top left and working my way across and then down to the denominator. So 2, the exponent is 1, so it stays right where it is. The t to the negative 3, because of that negative exponent, it becomes t to the positive 3, but in the denominator. Okay, now I move to the denominator, and I have 2 to the negative 3, so that's going to become 2 to the positive 3, but in the numerator. And then I have r to the negative 3 in the denominator. It becomes r to the positive 3 in the numerator. So the negative exponents switch from top to bottom, bottom to top, because it means the reciprocal of, or 1 over. Okay, and then I just need to simplify this. Okay, so I know 2 to the third is 8, because it's 2 times 2 times 2, not plus, times. So I get 8 times another 2 is 16, r to the third over t to the third. Okay, so I'm giving my answers so that I have no negative exponents. And I also don't want any 0 exponents. And for my classes, 3rd and 5th period, nobody asked any questions about 0 exponents. So let me just say this. If you have, let's say, 12 x to the third, y to the negative 2, z to the fourth, and I raise it all to the 0 power, I don't have to do anything inside the parentheses. That equals 1. Anything to the 0 power equals 1. Okay? All right. So now let's move on. All right. Jason is asking for page 92, number 55. Okay, page 92, number 55. Okay, very similar to the problems we were just doing. So in the parentheses, we have a fraction, 3a to the negative 1 b squared over 2a b to the negative 3, and then the whole quantity is raised to the negative 1 power. Okay, I think I'm going to start inside the parentheses, not necessarily the order you have to go. Like you could deal with that negative 1 exponent first if you wanted. I kind of prefer to deal with within the parentheses and simplify my fraction first, and then I'll worry about that outside exponent. So I'm going to write my negative 1 on the outside so I don't forget about it. Okay, I hope you're catching on that I keep doing this. Go systematically. Start from the left, work to the right. Don't jump around because you're going to forget something if you do that. Okay, so my 3, the first factor in the numerator, is to the first power, so it stays right where it is. The a goes down to the denominator, becomes a to the positive 1. I don't need to write the 1 though. Okay, b squared has a positive exponent, so it stays right where it is. Okay, now I'm in the denominator. That 2 has a positive exponent, so it stays where it is. This a is already in the denominator and has a positive exponent, so it stays. And then that b to the negative 3 is going to become b to the positive 3, but up in the numerator. All right, I'm going to simplify. So I have 3 times b to the 5th. I kind of thought to myself there, oh, I'm multiplying like bases, so you keep the same base and add the exponents. Okay, and then denominator, 2 times a squared. All of this is to the negative 1 power. Since I have a fraction being raised to a negative exponent, I think of that negative sign as being the reciprocal of. Okay, this symbol, let me write it in red, just the negative part of my exponent means either 1 over dot, dot, dot. I think of it as that if I have a non-fraction. Okay, or if it is a fraction, I think of it as the reciprocal of dot, dot, dot. Okay, so here I'm going to say this negative means the reciprocal of this fraction. And so we have 2a squared in the numerator and 3b to the 5th in the denominator. And then all of that would be to the positive 1 power, but I don't need to write that. So there is my final answer. No negative exponents. Okay. All right, Jason, I hope that was helpful. All right, Emma is asking for number 21 on the same page. So page 92, number 21. Okay, let's see. This gives us a big old mess of an expression, and then they want us to substitute x equals 2 and y equals 3. Okay, I am going to write the original that was given first. Okay, so we've got bracket 2x, the quantity, 3 minus y, and then close brackets, and then minus parentheses 7 minus y, that quantity times 2x minus 3y. Okay, parentheses and brackets are very important here. Let me see what we're substituting. This in red. So we want x to equal 2 and y to equal 3. Okay, so I'm just going to write a 2 in red here for this x. Y is 3. Y is 3. X is 2. Y is 3. Okay, then I don't know that I need to do this in different colors, but I'm going to. Then I'm going to write everything else the same. So this is 2 times that, the quantity, 3 minus that, minus the quantity, 7 minus that, and 2 times 2 minus 3 times 3. Okay, so here in the brackets, I have 4 times 0. So this is just 0. Okay, then I have my minus sign. This is 4. 7 minus 3 is 4. And then here I have 4 minus 9. And so I have a minus sign. This 4 here. This is negative 5. So really I have negative 4 times negative 5 is positive 20. And that's my final answer. Okay. Okay. That was number 21 on page 92 for lost my chat box. 21, that was Emma. Okay, Gianna is asking for number 67. 67 on page 93. All right. All right, it says perform the indicated operations and write the results in simplest form. All right, so page 93, number 67. All right, so here we go. We have a trinomial, 6x squared minus 3x plus 1 times a binomial. And personally, I would probably have written the binomial in front of the trinomial, but I'm guessing you guys probably didn't switch it, so I'm going to leave it the way it is. And by the way, you can get some practice as you're doing problems. They didn't even ask for names, okay? But you should be practicing your names of your polynomials. So the first factor has 3 terms and the degree is 2, so that's a quadratic trinomial. The second factor has only 2 terms, but the degree is 3, so that's a cubic binomial. Okay, so I'm multiplying a quadratic trinomial times a cubic binomial. You need to know those names. Okay, let's see. I'm going to use red. I'm going to circle this, and I'm going to distribute once and twice, and I'll write those down. Then I'm going to go to my second term, negative 3x, and I'm going to distribute once and twice. And finally, I'll go to my third term and distribute once and twice. So I'm going to do the distributive property 6 times here. Okay, my 6x squared times 5x cubed. First I do the 6 times 5, that's 30. My x squared times x cubed, if you're going, shoot, I don't know what to do with the 2 and the 3. Say the property. I'm multiplying like bases, so you keep the same base and you add the exponents. See how knowing your properties makes it so easy and not a guessing game. Okay, next I'm distributing that 6x squared to negative 3x. Be very careful with your signs. A positive times a negative is negative. I get minus 18 x to the third. Again, I'm multiplying like bases, so I keep the same base and I add the exponents. The exponent to that x is a 1, so 2 plus 1 is 3. Okay, next I'm on to my middle term, the negative 3x. So I distribute it to 5x cubed. That gives me negative 15x to the fourth. And then when I distribute it to the negative 3x, a negative times a negative is positive. My 3 times 3 is 9. And my x times x, I'm still multiplying like bases, so I keep the same base and I add the exponents. 1 plus 1 is 2. Okay, finally, I have the third term plus 1 that I distribute, and so that gives me a plus 5x cubed minus 3x. And so now I just need to look for like terms. I have a 5, a 4, 2 3s. These are the only like terms, I believe. 2 and 1, yep. Okay, so here's my final answer. 30x to the fifth. Oh, Bear, come here. Come here, Bear. Bear. You want to meet my puppy? Okay, 30x to the fifth. Bear, are you coming? Come here, Bear. Come meet my students. There he is. Come here, Boo Bear. Okay, come say hi to my students. All right, this is my little Boo Bear. Say hi, Bear. Hi. Study hard. Over-prepare for this test. See, Bear agrees with me. Hi, my Boo Bear. Okay, thank you. All right, that's one of my puppies. The other one doesn't want to say hi to you. Sorry. She's a little bit shy. Okay, so 30x to the fifth. Next, I want my minus 15x to the fourth. So those two that I circled are like terms. That's a plus 5x cubed, right? Yes, it is. And so I have minus 13x cubed. By the way, I kind of like to cross them out as I write them. So I got my x to the fifth. I got my x to the fourth. I combine those two x cubes. Okay, so I just kind of know like what I have worked with already and what I still need. Oh, I still need my plus 9x squared and then my minus 3x. Okay, so here is my final answer. And let's see, that's 1, 2, 3, 4, 5 terms. So I would call this a quintic because the degree is 5. And by the way, notice I started with the highest degree and worked my way down in descending order. That's how you should do it. They don't always do that though, so be careful when you're naming a polynomial. They could mix them up, and so you have to be careful about that. But this is a quintic polynomial. There's no special name for 5 terms, so I'm just going to say a quintic polynomial with 5 terms. There you go. Okay. Okay, let's see. That was number 67. That was Gianna's question. All right. Thank you. Cool. Thanks. And then Katie is asking for page 37, number 33. And we need somebody else to ask some questions. Okay, it's only 8:25. We still have more time. Assuming you want to ask questions, so don't be shy. Write some questions down there, guys. Okay, so let's see. Katie, page 37, number 33. Okay, and Gabe, I see you asked some questions. Thank you. Okay, let's see, page 37, number 33. Okay, I'm guessing that it is, this is section 1.4, by the way, that it's the fractions that are kind of freaking you out a little bit, so we'll talk about that. Okay, I have 1/3 x plus 1/2 y, and they want us to multiply that by 1/3 x minus 1/2 y. By the way, that's the sum and the difference of the same 2 terms, so something special happens. So we multiply those kinds of binomials. I can also call them conjugates of each other because only the sign in the middle is different. Okay, so I'm going to FOIL these, okay? So that means I'm going to go, let's go red here, the firsts here, and then the outers there. Well, if you look at what I just did, didn't I really just take this first term and go distribute 1 2 times? And then, let me circle this, when I do my inners and then my lasts, isn't that just taking the second term and distributing 1 2 times? So it's very systematic, okay? Yeah, I know they call it the FOIL method, but it's really just the distributive property 4 times, and you do it systematically. Okay, so my 1/3 x times my 1/3 x. When you multiply, I don't know that this is what you're struggling with, but when you multiply a fraction times a fraction, you just multiply it straight across the numerator. That's 1. And then 1 times 1 is 1, and then my 3 times 3 in the denominator is 9. So you just get 1/9, and then my x times x, I'm going to say my property again. I'm multiplying like bases, so you keep the same base and you add the exponents. I get 1/9 x squared. Okay, my outers, I'm going to go ahead and multiply these out so you can see, but something special is going to happen. But let's multiply anyway. Okay, first I'm going to multiply 1/3 times negative 1/2. So first my sign is negative. My 1/3 times 1/2 is 1/6. I just multiply the 1 straight across, and I multiply the 3 times 2 straight across. Okay, then I have x times y, so that's xy. Okay, now I'm on to my plus 1/2 y times positive 1/3 x. Okay, I'm doing the inners, so I get a plus sign. My 1/2 times 1/3 is 1/6. And then instead of writing yx, which you might be tempted to do, remember I made the comment earlier, I'm not sure if it was in this class or if it was in Algebra 2 Trig earlier in my GBL, but I want to put my variables in alphabetical order. So I'm going to put x first and then y. And a little squiggle right here. Okay, and then finally I'm multiplying the 1/2 y times negative 1/2 y, so I get minus 1/4 y squared. Okay, so look at my 2 middle terms. They are like terms, made much easier to see that they are like terms by putting xy and then xy, but one of them is positive 1/6 xy and the other one's negative, so they cancel out. That always happens with conjugates. Okay, all right, so my final answer is 1/9 x squared minus 1/4 y squared. Okay, and since they wrote their original problem with the coefficient in front, I'm going to write it the same way. But just to let you know, you could have written x squared over 9 minus y squared over 4. That would also be correct. Okay, all right, just letting you know. All righty, that was Katie's questions. So Gabe has a couple of questions. All right, so Gabe's questions are on page 92, and let's start with number 23. Okay. What a mess that is, huh? It's another one of those plug-in problems. Okay, I hope I can write this all the way across. So number 23, we've got brackets and then in parentheses, x minus 4 times the quantity y plus 2. This is where we're going to plug in for x and y. Then minus the quantity, 3x minus y. That is times 7 plus y. And close brackets. And then divided by parentheses x plus y. Okay, this is where we are plugging in an x equals 2 and a y equals 3. Okay, so like I did on the other one, I'm going to plug those in red. So x is 2, y is 3, 2, 3, 3, 2, 3. Okay, and then I'm going to go back and write the rest in blue. Okay, so I have a bracket, parentheses, minus 4, close, parentheses, 3 plus 2, close, minus 3 times 2, minus 3, close, 7 plus 3, close, bracket, close, and this is divided by, oops, 2 plus 3. I should have been up there, but that's all right. Okay, so let's see here. I'm going to do this in black. Okay, my 2 minus 4 is negative 2. My 3 plus 2 is 5. Put this bracket here. Minus, this is going to be 6 minus 3. Okay, 6 minus 3, so I get 3. Then my 7 plus 3 is 10, and then close the brackets, divided by 5. All right, in my brackets, I've got negative 10 minus 30 divided by 5. My negative 10 minus 30 in the brackets is negative 40. I'm going to write divided by 5 like this as a fraction, and my final answer is negative 8. Okay, notice I did not try to do that in my head. I did it step by step by step. I worked inside my parentheses first, simplified, simplified. Okay, it took me, let's see, 1, 2, 3, 4 lines to get to my final answer. Do not be afraid to show your work for your own good, not necessarily because I'm just asking you to do it. I mean, you should, but that's how you do these problems. Okay, let's see. Gabe also wanted number 24 on that same page, and I think that's the last question, so somebody else ask a question, please. Okay, let's see, page 92, number 24. Wow, these are kind of crazy looking, aren't they? All right, we've got this big old fraction in the numerator. You know what? I'm going to substitute as I go. So I know my x is 2 and my y is negative. Excuse me, my x is 2 and my y is 3. But in this problem, it says negative x, so I'm writing negative 2, and then times negative y, so that's negative 3, minus y, so that's 3, the quantity, and there's a fraction here. It's 2x, so I'm going to write 2 times 2, plus y, so that's plus 3. Denominator, 2x, so 2 times 2, and then minus y, so minus 3. Okay, in the denominator, it says x minus x, so 2 minus 2, the quantity. So we'll talk about that 2 minus 2 in a minute. Then in the fraction, I have 2 plus 2 times 3. Denominator, 3 minus 2 times 2. Okay, so I want to talk about that 2 minus 2 in the denominator. Do not subtract those and say, oh, it's just 0. No, it's not. This is 2 minus 2 times that quantity. Okay, you have to do your parentheses first. Okay, in the numerator, I am going to multiply my negative 2 times negative 3. That's positive 6. Then I'm going to go minus 3, and then I'm going to go and simplify this fraction. So in the numerator, I have 4 plus 3, that's 7. In the denominator, I have 4 minus 3, that's 1. So put another fraction sign. This is just 6 minus 21. So I have negative 15 in my numerator. Okay, now I'm going back to my denominator. I have this 2 minus 2 times, I'm going to simplify that fraction. I have 2 plus 6, that's 8. In the denominator, I have 3 minus 4, that's negative 1. Okay, so I have 2, and then my negative 2 times my negative 8 is plus 16. So that becomes 18, and since 3 goes into 15 5 times, but I've got a negative, let me put that so I don't forget it, and 3 goes into 18 6 times, my final answer is negative 5 over 6. Ta-da! All right, so I agree it looks like a mess at the beginning, but see how I'm trying to stay neat and getting organized and showing my steps and doing it in the right order of operations. Okay, let's see, Gabe, I hope that was helpful. Okay, next we have Cheyenne, page 37, number 21. And Emma also has a question on page 37. All right. Page 37, number 21. All right, there is definitely something a little tricky about this one, I think. So 1 plus x in parentheses, then I have brackets, 1 plus x, but those are not in parentheses. So we'll talk about how that differs. And then 1 minus x squared, and close the parentheses. Okay, so normally we say start with the parentheses, but the innermost parentheses is 1 minus x squared. There's nothing you can do to simplify that. So your first step is distributing this x to each of these terms. Okay, this is not a 1 plus x in parentheses. It's 1 plus, and then this x needs to get distributed. So I end up with 1 plus x minus x cubed. Okay, so now I have no parentheses inside my bracket. None of those 3 terms are like terms. By the way, that's a cubic trinomial in the brackets. And then out here, I have this 1 plus x. So I have a binomial, a linear binomial, times this cubic trinomial. Okay, so I'm just going to go systematically. In blue, I'm going to take the white and distribute 1. Did I say the white? I did. I'm going to take the 1 and distribute it to 1, 2, 3 terms in the trinomial. Then I'll take the plus x and I'll distribute it 1, 2, 3 times. Okay, so it's just 6 distributive properties. Should be easy. We didn't talk about Punnett squares in every class, but I would like you to try to do distributing like I'm doing here without having to rely on the squares. Okay, so I get 1 plus x minus x cubed. Next, I'm distributing the plus x, so I get plus x squared minus x to the 4th. And if any of those are causing you problems, you probably need to say your property. When multiplying like terms, you keep the same base and you add the exponents, and that'll tell you what to do. Okay, I know you're probably not fond of putting a negative as the coefficient of the first term, but I'm going to go in descending order. And so I've written my negative x to the 4th. Next, I'm going to write minus x cubed, and I'm going to cross that out. Next, I'm going to put plus x squared and cross that out. And then, oh, I see that I have like terms there. So I add those together and get plus 2x, and I cross those out as well. And my last term is plus 1. Okay, now it's possible on this problem that they may have in the back of the book written it in reverse order, starting with the 1 and then writing 1 plus 2x plus x squared minus x cubed minus x to the 4th. And there's nothing wrong with that. Usually, I would say it's more typical, though, that you start with the highest degree and work your way down. And then you should try to give this a name. Let's see, there's 1, 2, 3, 4, 5 terms. So this is a quartic, because the degree is 4, polynomial with 5 terms. A quartic polynomial with 5 terms. That's how you name it. Okay. All right. Let's see. That was for Cheyenne. I hope that was helpful. And last question, Emma, number 53 on the same page. And I say last question that you guys have asked, but we still have 20 minutes if you still have questions. All right. So Emma, page 37, number 53. All right. There it is. Okay, it's a trinomial, and they want me to square it. So it's a plus 2b plus c and it's the quantity squared. But you know what? I'm going to cross that out, and I'm just going to rewrite this trinomial. Okay, because they want me to square it, so that means multiply it by itself. All right, you're never going to see me do boxes. Okay, never, never, never. All right, so I'm going to circle this, and I'm going to distribute 1, 2, 3 times. It's supposed to go to my C. Okay, so I get a squared. Next, I get plus 2ab. Notice I just did that in alphabetical order, plus ac. So that's my first multiplication or distributive property. I'm going to do this in different colors so you can see what's what. Okay, next I take my plus 2b. I'm going to distribute to the first, to the second, to the third term. Okay, so I get plus 2ab. Notice I put that in alphabetical order. Very important, because if you put plus 2ba, you probably won't realize that it's a like term with this one right here. Okay, so 2 plus 2ab plus 2, ooh, almost made a mistake. My 2 times 2 is not 2, it's 4. So plus 4b squared, and then plus 2bc, of course, in alphabetical order. Okay, next, I'm going to take this c plus c, box it in black, and I'm going to the first, to the second, to the third. Okay, so I get plus ac, notice alphabetical order, plus 2bc plus c squared. Okay, so I have 9 terms, and I need to see if any like terms combine. Okay, so I've already underlined the ABs. Let's see. Oh, there's an AC and an AC. And I see I'll double underline a BC and a BC. And then I have single A squares and B squares and C squares. Okay, so it's a little awkward to like, what order should I put these in? What should I do? Well, I'm for sure going to start with a squared, so I'm done with that. Let's cross that out. I don't really know. I guess I'll go plus 4ab, 4ab, so that ab is gone, that ab is gone. Maybe I'll do my ACs next, I guess. So that's plus 2ac. Those are gone. And then I suppose I'll do my plus 4bc. So those are gone. And I can see very easily now what's crossed out and what's not. I still have my plus 4b squared and my plus c squared. Okay, I don't know if that's the greatest order to put them in, but whatever. There it is. Okay, all right. And I wouldn't even try to name this because there's so many different variables going on. I suppose it's a quadratic polynomial with 2, 4, 6 terms. Okay, there you go. Okay, I hope that was helpful. Emma. Okay, Andrew has a few questions, 2 questions. Okay, yay, we have some questions. Look at this. All right, so Andrew, page 92, number 35. Okay, draw the graph of each inequality. Excellent. I think you guys need practice with absolute value inequalities. Okay, so this is an example of a less than one, and I'm glad you actually asked both questions, one with less than and one with greater than. Okay, so it's the absolute value of x. Now this is pretty basic with just the x, but that's okay. Once you get the concept down of an absolute value with a less than, then you should be able to do any of them, even if it's a little more complicated inside. For instance, 37 has x minus 3 inside the absolute value. It's not a whole lot trickier, but a little bit more than just the x. Okay, can you picture yourself living on Number Line Lane and Mama says, I'm going to let you go 1 mile. Wait, no, that's too far. I want you to go less than or equal to 1 mile. Well, if you go to the right from your house 1 mile, you're at 1. 1 mile to the left on Number Line Lane, you're at -1. And there is an equal sign, so I'm going to put closed circles on those. But Mama's saying stay closer to home than 1 mile. You can go 1 mile or less. So doesn't that mean, let me do this in red, that you're going to be close to home in between those two? So you can write this inequality as one statement, and it's so easy when you look at the graph. I write the -1 first. I write a less than sign. I write my x, which is what was inside the absolute value. Oops, that should be less than or equal to. Okay, then another less than or equal to, and then positive 1. And you are done. This is the answer. You guys should be able to do every absolute value inequality sign with a absolute value inequality with a less than sign as easily as I just did that. Okay, now I know you didn't ask for number 37, but I'm going to do it together with this so you can kind of see with a little bit of repetition how I'm doing exactly the same thing. Okay, so on 37, let me just label that this is number 37. It has the absolute value of x minus 3 is less than 4. Okay, I'm going to do exactly what I did here. Okay, look at that graph, how I have negative 1 to the left, positive 1 to the right, and x, the shading in between. I'm going to do exactly that same thing. I'm going to go negative 4 is less than. Now, instead of writing x like I had in the absolute value before, I'm going to write x minus 3 because that's what's in this absolute value problem. Then another less than, and then positive 4. Can you see that? If you live here, Mama's saying go less than 4 miles. So you can go to the right or to the left 4, so that's plus or minus 4, but you're going to go less than that. So it's in between. And now I do want to get x all alone in the middle, so I do this in red. I'm going to write plus 3 right there, and if I add 3 to that middle part, then I have to add 3 to all 3 parts, okay? So I get negative 1 is less than x, which is less than 7. That is my final answer. Isn't that so easy, you guys? Okay, that is how you do every absolute value with a less than sign. If you can do this, go from this statement to this, you should be able to do any absolute value with less than, okay? All right, next page, I'm going to go to the next question that Andrew asked for, which is number 36 on page 92, and I'm going to do 2 problems for this one also. Okay, so 36 says the absolute value of x, very basic, is greater than 2. Okay, so I'm going to kind of demonstrate this on a number line. So pretend you live here on number line lane. If your address is 0 and Mama says, you know what, I'm kind of tired of you being at the house. You've been here all summer. I want you to go away far. I want you to go 2 miles. No, you know what? Go further than 2 miles. So from your house, 2 miles to the right gets you to positive 2. 2 miles to the left gets you to negative 2. There's no equal sign there though, so I'm going to put open circles. Let me do it in a different color. Open circles on the plus or minus 2. And then Mama wants you to go more than 2 miles. So the shading is going to go out from the positive 2 and out away from your house from the negative 2. Okay, now the way you write these inequalities without the absolute value signs, since there are 2 sections of your graph, you have to write the word or. So I want you to think of this symbol, not just as greater, but great or than, to remind you that you have to write the word or. Okay, let's write the right one first. Isn't this x is greater than 2? Well, how easy is that? It's exactly the same statement that I had up above, just without the absolute value sign. And then over here, it's a little bit trickier, but just look at the graph. It's x is less than negative 2. X is less than negative 2. So the sign switches and the opposite sign is negative 2. Okay, and those are your 2 statements. Don't try to write those as one. You cannot. It has to be 2 separate statements with the word or in between. Okay, so there you go. And then I'm going to do number 38 in addition to that because it's the same concept, but a little bit trickier. Not much, but a little bit trickier because instead of just being an x inside the absolute value, it's an x plus 2 and then is greater than or equal to 3. Okay, so can you picture your house is right here, plus or minus 3, and we want to go out from there. So I'm going to go straight from this statement. I'm not even going to draw a picture. I'm going to write the word or. I'm going to write the one to the right. Not x, but x plus 2 is greater than or equal to 3. Well, that was easy. I just copied the inequality without the absolute value signs. Now to the left, I write x plus 2, same thing that's in the absolute value, is less than or equal to negative 3. And then you just solve them both. Okay, so let me switch to red to do my algebra. I'm going to subtract 2 from both sides. So I get x is greater than or equal to 1. And I have my word or, you have to write the word or. Here I'm also going to subtract 2. So I get x is less than or equal to negative 5. Okay, and let me graph that final graph. Now, I'm not sure from the 19 people here if they're all from my class or if there's some from other classes. Other teachers may ask you to graph a little bit differently, but if you're in my class, here's what I want you to do. I don't want a bunch of different numbers on your graph. I want negative 5 and I want positive 1. They are the only two numbers that I care about for this graph, okay? Because my graph is related to negative 5 and positive 1. So the negative 5, I want a closed circle on there because of the equal sign, and I want to shade to the left. Look at that, far away from your house. And then on the positive 1, I want a closed circle because there's an equal sign, and then greater than, so that's to the right. Look at that, away from your house. See, every single absolute value with a greater than sign is, the graph is going to go out. And every single, if I go back a page, every single absolute value with a less than sign is going to be in between. By the way, I see that I didn't graph this one over here. So I'm going to put negative 1, positive 7. Those are the only numbers that are important. I'm going to put open circles on them and shade in between. And there's your graph. See how both of my graphs are in between because it's less than. Go a distance that's less than some number. That means Mama wants you to stay close. But on the next page, absolute value with a greater than, Mama's saying, get away from the house, go far, okay? And the beauty of this, you guys, is that with absolute value, there are only 2 choices. It's either less than or it's greater than. So just practice those and you should be good at them and they shouldn't cause you stress. Okay, let's see. That was Andrew. Those were Andrew's 2 questions that I turned into 4. So next is Cheyenne's on page 93, number 71. Okay, page 93, number 71. All right, let's see here. They want us to cube that. Very good question. Okay, so it's 4x minus 2y, the quantity cubed, but I'm going to write it out 3 times. You should. 4x. Oops, 4x. Oh, I'm going to erase that. Thought it was a y. Okay, 4x minus 2y. 4x minus 2y, the quantity cubed. Okay, you can either multiply the first 2 binomials, or I'm going to suggest let's multiply the last 2 binomials. I just prefer for my next step to have a binomial in front, but it's really no big deal. Okay, so in this box, I'm going 4x times 4x. That is 16x squared. Then I'm going to do the outers. I get negative 8xy. I'm going to hold that in my head. The inners, I'm going to get negative 8xy. Okay, let me kind of show that with red arrows. So here's my negative 8xy, and then here's another negative 8xy. So when I combine those together, I get negative 16xy. Notice I put those in alphabetical order. Okay, next I want the negative 2y times negative 2y. For some reason, that is usually where students make mistakes when they're multiplying 2 binomials. The negative times the negative is positive. If you mess that up, you just messed up the whole problem. Your 2 times 2 is not 2, it is 4, and then I have y squared. Okay, so I got a trinomial from the product of these 2 binomials, and then I still have this 4x minus 2y as a binomial in front of that. Okay, so here we go again. We're distributing. I'm going to take 4x and distribute it 1, 2, 3 times. When I do that, I'm going to get 64x cubed minus 64x squared y plus 16xy squared. Okay, notice I'm keeping my variables in alphabetical order. Okay, next, let me switch colors. Kind of see the different steps. I'm taking negative 2y. Be very careful when you're distributing a negative. And I'm going to distribute it to the first, to the second, to the third. Okay, I get negative 32 x squared y, see, alphabetical order, plus 32 xy squared, and then minus 8y cubed. Okay, I have 6 terms. Let's see if any of them are like terms. Let's see, I have an x squared y here and an x squared y there. And then I have an xy squared here and an xy squared there. So now I'm ready to add my like terms. Okay, first term, 64x cubed. There's nothing to combine with that, so I'm done and I'm going to cross it out. Next, I'm going to do the x squares because see, I'm starting with x cubed, so I'm going to go down to x squared. So the x squared y, I have negative 64 of those, minus 32 of those, so I get negative 96 of those x squared y's, and those terms are gone. Now my circled ones, those are xy squared. I have plus 16 plus 32. That adds up to plus 48 xy squared. Those are gone. And my last term is minus 8y cubed. That's my final answer. And if I gave this a name, I would call it a cubic polynomial with 4 terms. And there you go. Okay, am I done? I have one more question. Okay, we have time. So Katie's question is the last one. All right, Katie has for us page 92, number 38. All right. Oh, Katie, I already did that one. You probably know that. So somebody had asked for 35 and 36, and I went ahead and did 37 and 38 together with it. So I've already done it. Go back and look. Okay, I think we're going to call it a night here. So I hope that was helpful for you guys. I will see you all tomorrow. Come with lots of questions tomorrow. And keep in mind that I will be there after school tomorrow for an hour if you also want to ask more questions then. Remember, we are over preparing for this test, okay? I want you to get A pluses, not Fs, and you have to transfer out of this class, okay? So over prepare. All right, have a nice evening. I'll see you guys tomorrow.